So, chapter 5 is going to be mostly about triangles. We're going to be talking about congruent triangles, classifying triangles, finding measurements of different triangles, all about triangles. So today we're going to focus on the angles of triangles and congruent shapes. We're going to classify triangles, learn how to name them, learn what's possible, not possible, things like that. So classifying triangles. Triangles can be classified, and by classified I mean like named, right? We can give them a name by either their sides or their angles or both. So some of these vocab words might sound familiar to you. If they do sound familiar, I would love to hear from some different people. If we classify a triangle by its sides, we can have scalene, isosceles, or equilateral triangles. Does anyone know what a scalene triangle is, Charlie? No. Yeah, very good. None of the sides are congruent. You can say all three sides are different lengths, or you can say none of the sides are congruent. I'm going to say none of the sides are congruent. Now, when we classify a shape, different labeling might be given to you, or if you need to draw a shape, you might have some different ways to label this. If you want to indicate that all three sides are different, you could either put different numbers of like congruent marks in them, like maybe put 1 dash, 2 dashes, and 3 dashes. Or you might physically see different numbers there, different measurements, like maybe it tells you this side is 10 units, this side is 14 units, and this side is 15 units. All right, so that could be written in a few different ways. Isosceles. Does anyone know what an isosceles triangle is? Mark. Right, 2 congruent sides. An isosceles triangle is going to have 2 congruent sides. So those will always be marked as congruent, or it'll give you the equal measurements. If you have 2 congruent sides, does anyone know what else you might have? 2 of the sides are congruent. What else might happen, Charlie? Yeah, 2 equal angles is actually, or 2 equal sides is going to make 2 equal angles. And it's actually the angles on opposite sides. We talk a lot more about that next class, but it's just good to talk about today as well. So if these 2 sides are congruent, I just want to mention the fact you're also going to have congruent angles on either side. And then equilateral. Equilateral, you've probably never heard that phrase, but kind of dissect the word and it should tell you what it means. What do we think equilateral means, Evelyn? All the sides are equal, exactly. So in an equilateral triangle, all 3 sides are congruent. And people at home, feel free to chime in as well. I want to hear from you guys. So they'll all be marked as congruent. So all 3 sides are congruent. Equilateral, equal, and like lateral means like lateral faces or like sides. Just a different word for it. Okay. Classifying by angles. You can either have acute triangles, right triangles, obtuse triangles, or equiangular triangles. We've talked about acute, right, and obtuse before. But what do you think is going to make a triangle an acute triangle? Bridger? Not the sides, but the angles. Yeah, angles can be acute. And it has to be all of them. All 3 angles have to be acute. So if it's an acute triangle, all 3 angles are acute. Can someone remind us what acute means? Mark? Less than 90 degrees. So all 3 angles are going to have to be less than 90 degrees. So for example, maybe this angle is 70 degrees, maybe this angle is 50 degrees, and maybe this angle is 60 degrees. Right? All of those are acute angles. Did I pick 70, 50, and 60 just because I feel like it? Or do you think the angles of a triangle, something special always has to happen with them? 180. Yeah, all the angles of a triangle have to have a sum of 180. Okay, so whatever you see, or if you're picking things for labeling, make sure they add to be 180. That's a property we'll talk about on the next page. A right triangle, what's that gonna have to have? A right angle. Yeah, exactly. Can it have more than one? No. Any ideas why it's not possible to have more than one right angle? Liam? Wouldn't be a triangle, right? Doesn't a triangle have to have a sum of 180? If you have two right angles, isn't that already 180? There's no way, and try to visualize that. If you have like two right angles, that a triangle shape just isn't gonna happen. It won't close properly. So a right triangle is just gonna have one right angle. And that will either be labeled with a 90 or the box to indicate that it's right. An obtuse triangle, somebody at home, somebody online, what do you think an obtuse triangle is going to have? Yeah, exactly. Just one obtuse angle. Think about what we just talked about with the right triangle. If it's not possible to have more than one right angle, is it going to be possible to have more than one obtuse angle? No. So an obtuse triangle is going to have one obtuse angle. Can someone refresh our memory about what obtuse means? Bridger? Greater than 90 degrees, exactly. So maybe but less than 180. So maybe like that angle's 120, something like that would work. Good, and then equiangular, somebody at home, who has an idea of what equiangular might mean? Equiangular. Yeah, thanks, Mariah. Equiangular, equal angles, right? All the angles are going to be congruent. So all three angles are congruent. And they'll either be marked with the little congruent signs. All three angles in a triangle have to add to be 180, right? Well, if they're all congruent, what do you think that means about any of their measurements? Liam? They're all going to have to be 60. If you take 180, split it into three even parts, that's going to have to be 60 degrees for each. And then something else. Yes, AJ? Yeah, sure. If it's equiangular, what else do you think it's going to always have to be? Think about what we talked about with the isosceles triangle. Charlie? Yeah. If a triangle is equiangular, it's going to also have to be equilateral. Those two classifications always go together. If a triangle is equilateral, it's equiangular. If it's equiangular, it's equilateral because congruent angles make congruent sides and vice versa. And we talk about that property more next class, but that's just something that is helpful to mention. Okay. Questions about any of those? All right, we're going to practice classifying. I have no doubt this will show up on a quiz or a test. Okay, so this one second, Mark. It says classify each triangle according to its sides and angle measurements. I see a 90 degree, a 23 degree, and a 67 degree angle. None of the sides are labeled. Mark, what are you thinking? Okay, a scalene right triangle, I agree. I hope that the right part is obvious because you guys see the 90 degrees. How did Mark decide that it's scalene even though I have no side measurements? Evelyn? Take a shot at it. Take a shot at it. Exactly. Yeah, no, exactly. I don't know. I have no idea how long segment KL is, right? But if all the angles are different, Aren't all the sides going to be different too? It's kind of like the opposite of what we just talked about, right? If all the angles are the same, all the sides are the same. If all the angles are different, all the sides are going to be different. Liam, question. Right, exactly. And those will be labeled in some way, most likely. Bridger? Oh, sure. Give me 1 second. And when you write this one, I don't care what order you put it in. You can put right scalene or scalene right. Doesn't matter that much. Or at least I've never cared. Bridger, what are you thinking about number 2? I agree. Why do you decide to choose isosceles? Mm-hmm. Yeah, exactly. Angles N and O are both 30 degrees, right? And it gives you the 2 congruent sides here with the little tick marks. And we know that angle P is a 120-degree angle. So that is going to make it obtuse isosceles. Good. And then number 3. Charlie, what do you think about number 3? Exactly. Do we have three different sides marked as congruent? Yes. Are all 3 angles 60? Yes. So all the sides are congruent. All the angles are congruent. This is equiangular. Ooh, spelled that wrong. Equiangular and equilateral. Good. Questions yet? Question or answer, Mark? Oh, don't claim a spot yet. All right, so example 2. Draw the following if you can. Now, a few things about the diagrams for these. You're not likely to have to draw one on your test because Canvas. Okay, on a normal year, you'd have to probably draw one. But you will likely have to tell me whether something's possible or not. And sometimes it helps to like sketch it out and be like, can I make this happen? When you make sketches, I recommend labeling angles and sides. So ways to think, like, is this possible? I would say that shapes aren't normally going to have 2 side classifications at the same time or 2 angle classifications at the same time. For example, can something be isosceles and scalene at the same time? No. Can something be, can you have an acute right triangle? No, right? So those are like big like things to look at, like absolutely not. And then there's other certain things that can't be paired together. Do you think it's possible to be both acute and isosceles at the same time? Absolutely. Acute just means that all the angles are less than 90, right? And isosceles just means 2 of the sides are congruent. Do those like contradict each other in any way? As long as they don't contradict each other, then it's fine. I would probably draw this like maybe a tall, tall, skinny triangle. Mark your 2 sides as congruent. Yeah, you could do that. And I'm going to label them with actual measurements. I'm going to put 70, 70, and 40. Oh, not 140. Is it? It's my go-to because it adds up easily in my head. So that would work. And there's a lot of different ways to draw it. That's just one example. Right scalene, Mark. Well, first of all, is it possible? Okay, it is possible. Yeah, I mean, example 1 is a right scalene triangle, right? So hopefully we realize that's possible. Bridger? Oh, okay, 1 second. Okay, so we're gonna have a right triangle here. What, if you draw a right triangle for me, what absolutely has to be in it? You need your right angle box. Kaylee, stay off your phone, please. And then the other thing I would do is probably label your sides that all three are going to be different. Okay. All right. And then number 3, Bridger, what were you thinking about for number 3? Why do you think it's not possible? Right. You can't have both. They can't all be 90, right? It wouldn't be a triangle. And this is a perfect example of two things that contradict each other. If it's a right triangle, it has to have a right angle, right? But if it's equilateral, isn't it also going to be equiangular? And they have to be 60. It can't be 60 and 90 at the same time. Did you have a question, Liam, or no? Okay. So yeah, this we would say is not possible. Good, not possible. And then what about for number 6? Equiangular and scalene. Charlie? Not possible. How come? If it's equiangular, isn't it also equilateral? And can you be equilateral and scalene at the same time? No, these contradict each other as well. We would say not possible. Good. So then for this next part, hold on, Mark. Okay. For this next part, we are going to solve for some missing variables. This is going to be a very common kind of problem in this chapter. I'm going to give you a diagram of some sort. You're going to have to decide what's congruent, or sometimes maybe what adds up to be a certain value, set up an equation. What kind of triangle is triangle ABC in number 1? Evelyn? Uh-huh. What about the sides? Not scalene. Linus, did you have an idea? It's obtuse isosceles. Now, the obtuse part, not a huge deal here, because do we have any angles labeled anyway? No, but the isosceles part's going to be important, because doesn't that tell you these two sides here are congruent? Right, and when things are congruent, we can set them equal. Does this 9x minus 1 really help us in this problem? No, because AB, it's doing its own thing. Yeah, it's labeled, and that's great, but it doesn't actually help us. You're going to set the two sides that are congruent equal to each other. So you would set this up as 5x minus 0.5 equals 4x plus 1, or the other way around. I just did this because I know it looks nicer. Does that make sense, ladies and gentlemen? Those two sides are congruent, so you set them equal to each other? Okay, yeah, and then this is just extra information. So then you go through and solve. I would subtract my 4x over to get x minus 0.5 equals 1, and then add your 0.5 over to get 1.5. The occasional decimal will happen here, just normally not an ugly decimal. Right, Ben? Yeah. All right. Number 2, Bridger. So I subtracted 4x over, right? That's where I got the x or the 1x from. And then I just added 0.5 over to get 1.5. If you set up your problem the other way, that's also fine as well. You just end up with negatives on both sides, and then you have to remember to divide both sides by -1. I tend to, when I have a problem like this, I tend to set it up so that the larger x value is on the left. So that way you don't end up with a negative x value, if it's avoidable. That's just what I do. All right, number two, we got to add some labeling in. If I just give you this, is this enough information to solve this problem? Do I know anything about my angles or sides? Yeah, we know nothing. So here's what we're going to throw in here. We're going to throw in some congruent angle symbols. I agree. I'm sure that you can, but I would love to hear from somebody at home because they're awful quiet today. Someone at home, Mark, please stop. So for number 2, somebody at home, if all the angles are equal, what else am I going to be able to know about a problem like this? What do we think? Casey, what do you think? If all the angles are congruent, what else are we going to be able to say? Okay, yeah, all the angles will be 60. What else does it maybe tell us? Does it tell us anything about the sides? Yeah, exactly. If all the angles are congruent, won't all the sides also be congruent? Yeah, okay. Now this problem, I always make sure I put it on here because it throws people off. The reason it throws people off is because you're like, oh, there's 3 things. But then you don't know what to set equal. The most common mistake with a problem like this, don't write this down because this is wrong, but this is what people tend to do. Can anyone tell me why this is incorrect? Why can I not add up these 3 values and set them equal to 180? This is what people tend to think because you're like, oh, 60-degree angles, right? Why is that not okay? Charlie? And what am I giving you? The sides. This problem, I'm giving you labels for the sides. Do the sides of a triangle add up to be 180? No, I don't know what the sides add up to be. That varies from problem to problem. Depends on how big your triangle is, doesn't it? I know that the angles add up to be 180. If these were angles, absolutely, that's a great setup to your problem. These are sides though. So never, ever, 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 ever add up sides and set them equal to 180. Doesn't work that way. Sides, angles, not the same thing. Bridger. Mm-hmm. Exactly. Yeah, if all 3 are the same, they're all equal, right? If they're all equal, does it matter which 2 I pick? Oh, pick whichever ones you like. Pick whichever ones look nice to you. I'm going to pick 2y plus 5 and 3y minus 1, just because I want to. You can pick the other one if you prefer. And I know they're equal, so I'm going to set them equal to each other. 3y minus 3 equals 2y plus 5. I'm going to subtract my 2y over to get y minus 3 equals 5. And then I'm going to add my 3 over to get y equals 8. And then that's it for that one. I don't overcomplicate it. Okay, if you're given sides, set them equal for the most part. All right, where are we at? I want to define a few things on the next page and then we'll take a break, okay? It's a little bit longer of a note set just because there's a few things we need to get through. So I want to do these definitions and then we'll take a break. So on the next page, finding angle measures of triangles. So we've talked about how to find sides, right? Determine what's congruent, set them equal. Angles are a little different. When we're dealing with triangles, we can have, yes, AJ. Yes, I got 8. Interior angles, and you can also have exterior angles. Interior angles, that's like this diagram here. It's these red triangles literally on the interior. But also too, you're gonna see some diagrams where like the sides extend almost, and that forms exterior angles. So the exterior angles, something we need to remember about them. The exterior angles are actually gonna form linear pairs with the interior angles. Remember a linear pair, that's when you have your opposite rays, right, with another ray kind of coming out of that opposite ray. Do you guys remember anything special about linear pairs? They have a special property. They're always something. Not congruent, What do you mean by even? Like even numbers? Not necessarily. That's congruent. Not symmetrical. Evelyn? Supplementary. They're always supplementary because don't you have opposite rays? Doesn't that form a straight angle? Isn't that 180 degrees? Yes. So something, and please write this down. Please add this into your notes. Interior and exterior angles are always supplementary. So the interior and the exterior angles are always going to be supplementary, which is going to help us when we're sometimes finding angle measurements. Because sometimes you'll need to use one to find the other. So for example, what that would mean here is if I told you this exterior angle was 120, the interior one would have to be 60. Okay. All right. The triangle angles are the triangle sum theorem. We actually already talked about that. The sum of the measures of the interior angles of a triangle is 180 all the time, no matter what. The exterior angle theorem says that the measure of an exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. What this means, now I'm going to warn you guys that this is a property that's most often used incorrectly. I'm not sure why, it just tends to be that way. Incorrectly. So what this theorem tells you is if you have an exterior angle, like angle 4, that's what an exterior angle is. What you can do to set up an equation with that is set it equal to the two what are called non-adjacent interior angles. I think of them as the interior angles on the completely other side of your shape. So angle 4 is going to equal angle 2 plus angle 1. You add up the two angles that are on the completely opposite side of your shape to get your exterior angle. It's not used in every kind of problem with an exterior angle, but it can be super helpful. Okay. So to get your exterior angle, add up your two interior ones on the other side of the shape. And then our last property for this part is the corollary to the triangle sum theorem. That says that the acute angles of a right triangle are complementary. Does anyone remember what complementary means? What does it mean? Yeah, they add up to be 90 degrees. Now, think about that. If you have a right triangle, like this triangle here, triangle ABC, you're going to have one right angle, right? If angle C is already a right angle, and you know all three angles have to add to be 180, well, what's 180 minus 90? 90. So don't angles A and B only have an extra 90 degrees to share? And aren't two angles that altogether equal 90 complementary? Yeah, so this is just saying to you basically if one angle's 90, the other two have to also add up to be 90. That's where that 180 comes from. Okay? All right, number 1. We want to solve for x. We have a triangle. In this triangle, all of our interior angles are labeled. We got a 70-degree angle, a 35-degree angle, and a 5x plus 15-degree angle. Any ideas on how we could set up an equation for number 1? Mark.
You take 70 plus 35, whatever that equals. You subtract it from 180. So you know the measurements of that third angle. Find x. You just plug in numbers until you get the equal value.
Or you could just solve the equation. Well, so part of what you said is a good strategy. The end part with the guessing and checking, not a fan of. But one way you could do this is that, yes, you could take 70 and 35, add them up to get 105, and then subtract that from 180. That means that this angle here has to be 75 degrees. So one possible equation is to set 5x plus 15 equals 75. Is that the only option, though? No. Does anyone have another idea of how we could maybe set this up? Abby? What would I set equal to 105? So not 105. You're thinking an exterior angle. If 5x minus 15 was on the outside here, then absolutely. So we don't want to set them equal to 105, but there is some stuff I could add up maybe. Linus? Mm-hmm. So I do want to add all three up, but I don't want to set it equal to 75. If I add all three angles, I want to set it equal to 180. So this was just one idea from what Mark said, right? Oh, and then I see what you're saying, yeah. So yes, Liam, you had your hand up.
70 plus 35 plus 15, and whatever that is, like
105.
Well, no, you take 70 plus 35 is 105, plus 15 is 120.
Mm-hmm.
So 5x plus 120 is 180.
Right. Basically, you add up all your parts, and how you guys decide to do that, and how you want to go ahead and combine like terms, totally up to you. But like the basic equation that you would set up is 5x plus 15 plus 35 plus 70 equals 180. Okay, that's like at its base level, that is the equation you would do. You add up your three angles, you set it equal to 180. Now, how you then decide to combine your like terms, subtract things over is up to you, but that's like the standard way to set this up. So then I would combine my like terms, and that would give me 5x plus, I think that's 120 equals 180. Subtract your 120 over to get 60. I think I added that up correctly. Now I'm second guessing myself. Hold on. 15 plus 35 plus 70. Yes, 120. Okay, good. Yeah, and then you would divide that to get 12. And you should still get 12 if you did it this way as well. Either way is fine by me. Do what feels comfortable to you. You're going to come back to number 3 in a second and try that one out by yourself. We are going to go down to 2 right now, though. For number 2, what's different about your diagram in number 2? Yeah, there's like this line is kind of extended out outside of your triangle. Good. What else is different? Okay. Bridger, what were you going to say? Right here? Okay, yeah, we are missing an interior angle. Instead of it giving us an interior angle there, what does it give us? It's giving us an exterior angle. Well, yeah, did we learn a property about our exterior angles? Mark? Right. My exterior angle equals my remote, what are called my remote interior angles added together, or the interior angles that are on like the other side. So my exterior angle is going to equal whatever angle T is plus whatever angle S is. So we would set this up by doing 13x plus 3 equals 9x minus 1 plus 40. So my exterior angle equals angle T plus angle S. and then you just solve your equation. I would probably combine like terms first and do 13x plus 3 equals 9x plus 39. What do you think I should do from here? Any suggestions? Doesn't do you guys any good if I just do all your algebra. Sure, let's subtract that 9x over. That'll give us 4x plus 3 equals 39. Then what should we do? Yep, I would subtract the 3. 4x equals 36, and then divide to get 9. I would say this is one of the more commonly missed problems, only because people forget that property. And if you forget that property, can you really do the problem? No. Okay, so that's a good one to have like your notes handy for. It tends to be something people forget. All right, and then let's take a look at number 4. It says find the measures of angles 1, 2, 3, and 4. So we got angle 1 up here, angle 2, angle 3, and angle 4. In this diagram, we are given a bunch of right angles. We're told that we have a 52-degree angle here and a 38-degree angle here. We are going to use the given information to find the angles it asks for. Now, something about a picture like this, you don't necessarily have to go in the order 1, 2, 3, 4. Do what you recognize first. Maybe there's some labeling that you could do in a certain situations, right? Just you almost want to go through, it's like a puzzle, right? Find somewhere where you know some information and then work your way around. Bridger? Mm-hmm. Yeah. Exactly. We have a little like triangle happening inside of our picture here, right? Bridger said we had a 90-degree angle, we had a 52-degree angle. Can you add those up and subtract from 180 to find the missing angle? Yeah, so that's what we're going to do to find angle 1. So the measure of angle 1 equals, and I'm going to do this in one step. You could do it, you don't have to do like one single equation if you don't want to. But I know that I need to take 180 minus what I have so far, which is 90 and 52. That's going to give me 180 minus 142, which is going to give me 38. So I know that angle 1 is 38. Somebody at home, what do you think I could do next? Any suggestions, people at home? Like on this side, Zach? Yeah, absolutely. Good. That's one thing we could see. Liam, you have an idea? Like up here? Yeah. Yeah. So Liam is suggesting we find 4 first. That works for me. Now with angle 4, what can be a little tricky about this one is, do you guys see a right angle box in that one? No, but if you have a right angle here and a right angle here and a right angle here, what are you going to have at angle T? A right angle. It's going to have to happen. It makes it a rectangle. If you only had 1 or 2 right angles, you can't assume it, but they have to be. This has to work out that way. So sure, you could find angle 4 in that fashion. So I'm going to say that the measure of angle 4 equals 90 minus 38. That's actually going to give you 52. You don't have to go there next, but that's what we're going to do because Liam suggested it. Somebody at home, where do you think we could go next? How could I use this information to find angle 2 or angle 3? Let me know that we're there and awake. Good. Yeah, for angle 3, we can use a similar strategy to what we did to find angle 1. Add up what you have so far, subtract from 180. So I will write that down here. Measure of angle 3. We're going to take 180, subtract what we have so far, which is 90 and 52. That's going to give us 180 minus 142, which is going to give you 38. Okay, so we know angle 3 is also 38. So somebody I haven't heard from yet, either in person or online, either way, how could I then find angle 2? How could I find angle 2? It's the only one left. Sorry, Charlie, I already heard from you. Want to hear from somebody I haven't heard from yet. Sorry, Evelyn. So who haven't I heard from yet? I don't really think I've heard from AJ or Joey or Kaylee or most of the people at home. I haven't heard from Alex or Kaylee Spencer or Mark Veer or Tishaylin or Trenton. I think I heard from Mariah and Casey and Zach Roof. I have an answer. Yes. So for number 4, the reason, so we could assume, well, we couldn't assume, we know that this has to be a right angle because all the other 3 angles are also right angles. Like angle Y is a right angle, X and W. Yeah, so that one has to be 90. If Bridger, if we only knew, like, let's say if we only knew that Y and X were, I would be worried to assume that, you know? But since we knew that all 3 of the other ones were, we could say the same about angle T. Yeah. Okay. Hopefully that gave you guys some time to think. Somebody I haven't heard from, how can we find angle 2? Joey, any ideas? Sure. Yeah, we could use this triangle here, right? And we could do that the measure of angle 2 equals 180 minus 90 and 38. That's going to give us 180 minus 122, which is going to give you a 58-degree angle. Was there another strategy I could have used there? Don't I know this whole angle is a right angle? If part of it's 38, could I also do 90 minus 38? Would it give me the same thing? Yeah, I don't care which way you do it. Okay, Liam? Oh yeah, what did I write? Oh, I wrote something incorrectly here, sorry. I'm glad you pointed that out. This should be a 128, not a 122. Why isn't my eraser working? I can fix that and make that a 28. And then this should be 52, sorry. I'm glad you pointed that out. It should be a 52. All right. I want you guys to try out number 3. Number 3. So people at home, we're going to go over number 3. So with this, I would say the big thing here to help you get started on this problem is vertical angles. You guys remember vertical angles? You can't forget about them, really. That's when you have your X shape and you have congruent angles on either side like this. Does that sound familiar? Okay. So if we know something like that occurs, right here, don't I have all these little X shapes? Got an X shape, got an X shape. So aren't I gonna have vertical angles? So someone tell me somewhere where I can start. Given what I have, what is another angle that I know? Okay, so where else do you want me to put a 110, Zach? Where else should I put? Okay, yeah, so it would go across from that 110. Those are vertical angles, good. What else can I do? Yeah, where would I get 70 from, AJ? Yeah, these are linear pairs. If one side is 110, the one next to it, subtract it from 180 to get 70. If I can put a 70 there, exactly, I can put a 70 on the inside there because those are also vertical angles. Mark.
60 is, you can, on both sides of it, subtract 60 from 120.
Yeah, so we would, just like here, we could do 180 minus 110. Then here, can't I do 180 minus 60? Yeah. So I'm going to have a 120 here. And then if you take a look, don't you still have your X shape? So won't we have vertical angles again? Okay, so I would have a 60 here. Yeah, and a 120 there. Okay, so somebody else, how can I now use this 70 and this 60 to get me to the other side of my triangle? AJ? Why a 50? Right, all three of my interior angles need to have a sum of 180, right? If I take 180 and subtract out 70 and 60, that's going to leave me with a 50. Somebody at home, where can I go from here? Yeah, good. My vertical angle would also be 50. Good, yeah. And then we're going to, again, have that supplementary angle situation. So 180 minus 50 is 130. Kind of like when we dealt with our angle relationships, for the most part, everything either ends up being congruent or supplementary again. Okay, so we can't forget about some of those old angle relationships. All right, questions about that? I would, that's definitely an example that I would maybe look at again if you were confused. So last thing we're going to talk about today is identifying and using corresponding parts. Corresponding is a fancy word for like matching. All right, so one of the big ideas this chapter is congruent triangles or congruent shapes in general. If two shapes are congruent, so if you have congruent figures are two geometric figures are congruent if they have the exact same shape and size. So everything about them is exactly the same. They're the same shape and the same size. So that means if I have one shape and I pick an angle from it, any angle, could I go to my other shape and isn't there going to be an angle that's exactly the same as it? Those are your corresponding parts, the parts that match up from one shape to the other. Congruent figures have corresponding parts that are congruent, which include angles and sides. So if two shapes are congruent, all their corresponding angles end up being congruent, and all their corresponding sides end up being congruent. So for example, in this diagram here, it says the two triangles to the right are congruent. So triangle ABC is congruent to triangle XYZ. That means if I pick an angle from the first triangle, it's going to match up perfectly with an angle from my second triangle, and that's what we're going to practice doing first. So which angle corresponds with angle A? So correspond, again, fancy word for like matching. If I pick out angle A is going to go with which angle in my other triangle? Mark? X. And you can kind of use what's marked as congruent to figure that out. So angle A is going to have to go with angle X. they would be congruent to each other. They're going to have the same measure. So then continuing with that, somebody else, B would have to go with what? Yeah, B would have to go with Y. And then that leaves angle C with Charlie, Z. All right. So now using that, we're going to write a congruence statement. What that means is say that one shape is congruent to another shape. When we do something like that, we cannot just write the letters in any old order that we want. Corresponding, the congruent parts have to go in the same order. So for example, if I say that I have triangle ABC, I need to say that is congruent to, and then when I name the second triangle, I have to put it in that same order. So whatever goes with A goes first, whatever goes with B goes second, whatever goes with C goes third. So exactly, I would have to call this triangle X, Y, Z. Because A goes with X, B goes with Y, and C goes with Z. Now, there are other ways I could name this, but if I change the order of one, I have to also change the order of the other. So give me a new name for triangle ABC. What's another way I could name that, Evelyn? Yeah, sure. What if I call this triangle, oh, except draw a triangle, not whatever I just drew. What if I called this triangle BAC? How would I then have to name my second triangle? If I go B, then A, then C. Mark? Right. B goes with Y, A goes with X, and C goes with Z. Okay? So I don't particularly care you name the first one, but the second one has to go with it. All right. Now, what if you don't have a picture? If you don't have a picture, it's okay. You can still identify your corresponding parts. You almost want to work backwards. In this first example, we used our picture to figure out our corresponding parts. But suppose that two triangles are congruent and have a congruent statement of triangle XYZ is congruent to triangle RST. State the three angles and three sides that are congruent. So this time we almost want to work backwards. I'm giving you a congruency statement, and you're going to use that information to decide what goes with what. Now, we've already talked about how don't they have to go in the same order? So look at the order they're written in. When you're dealing with a congruency statement like this, if you have triangle XYZ, that means X is a vertex, Y is a vertex, and Z is a vertex. So if one of my angles is X, that's going to have to go with which angle in my other shape? R, because those are both in the same position, right? This congruency statement tells you that angle X has to be congruent to angle R, because they're both first. So, knowing that, what else can I say? Give me another one. Charlie? Right, Y is congruent to us. They're both in the second position. So angle Y is congruent to angle S. Somebody at home, what else can I then say? I'm about to. Yep, Z is congruent to T. Good. So I can also then say angle Z is congruent to angle T. I can kind of use the same strategy now for sides. Remember, if you have a side of a triangle, it's going to have two endpoints, right? So if I'm going to name a side, you could call a side like X, Y, or Y, Z, things like that. So I'm going to kind of show you how to do the first one. When I talk about congruent sides, I would say something like segment XY is congruent to segment RZ. I grabbed the first two letters with the first two letters. So if that works, somebody at home that I haven't heard from yet. So that would be Alex, Mark Veer, Tashaylin, or Trenton. What else could I say? What would be another set of congruent sides? Alex, what do you think? If I can say that segment XY is congruent to segment RZ, what else could maybe work? I'll start you off on the one side. What if I told you that one of the sides was YZ? What could I say YZ is congruent to? ST, yeah. Exactly. Okay, so I got XY with RZ and YZ with ST. What would be the third combination? Charlie? Okay, XZ. Trenton, I saw you were going to say something. Trenton, what do you think that would go with? Yeah, exactly. XZ would have to go with RT. Bless you. Because XZ is the first and the last, so that would have to go with the first and the last. Good. Questions about how that works? Okay. All right. Example 6 in the diagram, triangle triangle RSV is congruent to triangle TVS. Find the values of X and Y. This is a great place for color coding, if you like color coding or have different highlighters or things like that, because it's giving you a congruency statement. It is telling you exactly what goes with what. So I like to color code my vertices, actually, my angles. So R's first, R is going to have to go with T. So whatever angle R is, that's going to have to be congruent to angle T. Then it also has S with V, so angle S in this first triangle is going to have to go with where V is in the second one. And then V is going to get paired with S. So where angle V is in the first one, that's going to go with S in the other. So it kind of helps you pair together what's congruent. So now knowing that, I got to find angle Y. I have to find the measure of Y and the measure of X. I don't care which one we do first, but does anyone have a suggestion? Okay, Mark, what's your suggestion?
24.
Yeah, absolutely. 24, that's side VT, right? If you look, side VT, isn't that going to have to go with side SR? Yeah, so I can set those equal. 2y minus 1 is going to equal 24. That's another thing that makes the color coding helpful. Isn't 2y minus 1 between blue and green? Isn't 24 between blue and green? So if you're kind of more of a visual learner, that could be helpful. So 2y, I'm going to add my 1 over to get 25. Don't panic. The occasional 0.5 decimal happens. This should be y equals 12.5. Okay. Now, with that, does anyone have a suggestion on how I could try to find x? X is over here with this angle. Good. Absolutely. Yeah, good. If I know, I have my congruent parts, right? So won't angle S over here have to be 78? And then if I have the right angle in the 1, isn't this also going to have to be a right angle? That's kind of hard to read here. I'll pick a different color. Let me make this blue. That's 78. So if I now have this triangle with a 78 and a 90, can I add those up and subtract to find my other angle? Yeah, absolutely. So to find angle X, I'm going to do, actually I'll do this in a different color. So to find X, I'm going to do 180 minus 90 and 78. That's going to give me 180 minus 168, which is going to give me 12. Do we see why this angle would have to be 78 and this angle would have to be 90? Okay. The color coding with that it can sometimes be really helpful. And I have highlighters and stuff if you guys ever want to borrow one. All right, last problem. Example 7 in the diagram, polygon BCDE is congruent to polygon RSTU. Find each value. Now with this one, if you take a look, isn't one like the flipped over version of the other? So again, using your congruency statement is going to be really important. I'm going to get you started, and then I'm going to give you a few minutes to try to figure it out, and then we're going to go over how to set each one up. You might not get all the way through it before we have to talk about it just because of timing. But angle, if you look at your congruency statement, B goes with what? B goes with R. Bridger, you awake back there? B goes with R. And then C goes with S. D goes with T. Yeah, D goes with T. And then here's D, here's T, and then E goes with U. This is a good example of don't ignore your congruency statement. It's there to help you, okay? Because it sometimes really confuses people when they see the 11 and the 12 because they assume that those go together. But once you've color coded it, can you clearly see that those don't go together? Yeah. All right, so take a second, try to figure out W, X, Y, and Z. All right, so Mark, to solve for W, how did you set up your equation? Yep, 4W minus 7 equals 2W minus 13. These two sides here would have to be congruent. Oh yeah, plus 13, sorry. So that would give you 2W equals 20. And for W, you should get 10. Abby, what's another equation we could set up? Good, 3Z plus 10 equals Z plus 16. These two sides would have to be congruent. You should get 2Z equals 6, and then Z equals 3. I'm running through the algebra quickly just because I think the setup is more important. Somebody else, what's another equation we could set up? How could we maybe solve for X? What could we set 2X? Guys, stop talking, please. What could we set 2X plus 9 equal to? Evelyn? 49, exactly. Isn't angle B going to have to be congruent to R? So set that equal to 49. 2X equals 40, and then X equals 20. And then last but not least, what are we going to have to do to find 2y minus 31? What would we set 2y minus 31 equal to? Evelyn? Yep. Doesn't D have to go with T? Aren't they both blue? They're in your congruency statement together, so that equals y plus 11. Subtract your y over to get y minus 31 equals 11. Oh, Joey, I think I told you the wrong thing for this one because I was thinking divide by 2. And then add that over. That should be 42. You can fix that. It should be 42. All right, this definitely shows up on a quiz or something, maybe more with a triangle, but this general concept. Liam, you had a question?